Good evening. Welcome to CSD Learns STEM Education webinar. This is our sixth in a series. And so throughout the months, beginning in October, until now, we've had a webinar every month. For those of you that have been with us for each one, welcome back. For any new attendees, welcome to tonight's webinar. Before I get going and we start the panel, I do want to make sure that your software is set up. You should hear the sound of the voice interpreter. We also have captions set up. There is a feature at the bottom of the software which indicates closed caption via an icon. You can go ahead and click on that and start the closed captions if you would like. Also, if you're experiencing any tech issues, go ahead and type those issues into the chat box and someone from our CSD Learns team will respond and assist you with those. Also, make sure that your Zoom software is using the most updated version. Currently, you should see a PowerPoint saying Zoom on it, and then you should also see 4 video screens for myself and the panelists. Now, if the PowerPoint is a size that you do not prefer, you can resize it. So make sure you set the proper sizes to where you're comfortable. And again, if you have any trouble doing that initial setup, go ahead and type your question into our chat box, and we'll have someone from the CSD Learns team help you with those issues. Another option that we will use tonight is our Q&A box. That is where you will be able to field any of the panelists your question for tonight. So if you'd like to ask a question, type that right into the Q&A box. I, Scott, will see that, and then I will go ahead and sign your question to the audience. Okay? Thank you so much. Again, feel free with any technical issues or concerns to reach out to us in the chat box, okay? So today's STEM education webinar is titled STEM Success in Higher Education. Now, what exactly is higher education? Well, that's after high school. College, universities, trade schools, anything that's post-high school training is considered higher education. The reason we've landed on this topic is because in order to aim for STEM careers, those careers necessitate a person have degrees, science degrees, and STEM field degrees. But the challenge in achieving a STEM career from the perspective of a high school student in a time when STEM was not a thing. So how did one prepare for those emerging STEM careers? So as you can see, I have a slide to kind of highlight that. You can see there's a picture of a videographer possibly filming traffic in the city. Now, that job has been done away with by a drone that could fly around and do the same work all day long. So let's say if in the past you wanted a job flying drones, you probably wouldn't because they didn't exist. So that's a challenge. How can we achieve those STEM careers without knowing what they are or having known what they were? So we will be covering that in tonight's webinar as well. I'll start by introducing myself. This is Scott Hohen speaking to you tonight. This is my sign name, Beyond the Ear. I am tonight's moderator for this webinar. I am a doctoral student focused on science education here at Georgia State University here in Atlanta. And now I'll go ahead and introduce the panelists. Panelists, why don't you tell us your names, where you're at, and what you currently do? Why don't we start with Anne?
Hi, everyone. My name's Anne, and I am a 4th-year PhD candidate in horticulture. And the reason why we use this sign for horticulture is because of the application of plant science. My focus is viticulture, which is the research of grapes, winemaking grapes, understanding the science behind how to grow grapes. And I also specialize in enology, which is winemaking, studying the process of winemaking. And I am at Cornell University. And that's in upstate New York, which is about 2 hours from Rochester. It's snowing a little bit here right now.
And thank you about that. And I did hear about the snow in New York. Yeah.
Yeah, it's crazy.
Now, do you mind telling us what you meant when you said you're a PhD candidate?
Me?
Yes, and you mentioned just briefly that you're a PhD candidate. What does that mean?
Oh, yes, I'm a PhD. So you have a PhD student and a PhD candidate. And the difference between the two is that each PhD student is required to have 3 exams. My program, at least, requires 3 exams. The first is the qualifying exam, which means you discuss your proposal, your plan, your lit review is studied, and you go in front of a committee and you discuss that plan. And once that is out of the way, the second part is a comprehensive exam, which is quite terrifying. I wrote for that for 16 hours, and I had a 3-hour oral exam plus 1 semester of writing more questions, going back and forth between writing questions and answering them between myself and my committee members. And once you pass that comprehensive exam, otherwise known as comps, every student hates the word. It's a detested word, but comps, once you pass them, you become a candidate.
Mm-hmm.
And when you're a candidate, you are able to independently research and take on your project independently, whereas a student is somewhat more guided in their approach.
Thank you so much for that, Anne. Thank you. I am a PhD student. My comps are coming up in the summer.
Oh, cool. Congratulations.
Yes, I will soon become a candidate. And I did just want that thoroughly explained for the audience. And each program has its own set of comps, and they all are also diverse and different. So, Anne, thank you for covering yours. And now let's move on to Eric. Go ahead and introduce yourself, Eric. Hi, everyone. I'm Eric Shear, and I'm a one-year master's student in chemical engineering at the University of Florida. In this area, Scott says, can you spell that area for us? Ginsville? Ginsville, Florida, says Eric. It's in the northern section of Florida. Scott says, thank you for that. This is Eric, but before that, I mastered in Earth and Space Sciences at the University of York, and I have a BS in Specialized Honors Physics and Astronomy from York University, and I studied for a Master's of Science in Earth and Space Science at York University. And so what I focus on is how to keep humans alive in space. And so that's the focus of my chemical engineering. This is Scott. Thank you so much for that. Moving along to Linda.
Hello. My name is Linda Campbell, and I'm a professor in environmental science with a specific focus on the aquatic system, whether that's lakes, rivers, streams, and looking at the impact and disruption of those aquatic systems and how to remediate that. I passed all of my comps a long time ago. I'm glad that's way behind me.
And so Linda, you teach now?
Yes, I'm an instructor and researcher, and of course, I serve. And what I mean by that is I go out and research scientific problems, sometimes interview for new publications, and just work with the public in how to remediate problems. I also work with the deaf population. I teach, the deaf community.
At a community program.
Yes, that's the service piece. Yes. And just really conservation of the earth, and making proper decisions related to that. Um, Environmental contaminants is one specific focus, from industrial pollution and man-made pollution. I research those contaminants and how to remediate them. It's somewhat, hard work, but it feels good to know I'm making a difference. And when I teach a variety of courses. Sometimes my first year courses are a large packed classroom of 300 students. Sometimes the PhD classes are just a group of 4, and we'll be able to dive in deep to any particular subject. So I teach a wide range of classes, and I really enjoy teaching.
This is Scott. Thank you so much, Linda. And also, I'd like to point out on our PowerPoint, you see 4 individuals in purple shirts. And they are the CSD Learns team. They are the team behind setting up our webinar for tonight and all the logistics that go into that. So we do want to extend our gratitude to them for the fantastic support that they provide. We also would like to acknowledge and recognize General Motors, GM, the vehicle manufacturer, yes, for a grant that was provided in support of this webinar and making it possible. So we would like to recognize and acknowledge General Motors in that. And this is Scott speaking. Okay, we're ready for tonight.
Ready to go.
And so the first topic I'd like to discuss is what makes you a Stemist? And the point of that question is really to get you to reflect on your youth and what really drew you into that STEM learning. So I'd like you to look back to when you were young. Did you like grass? Did you like stars? I'm just really curious by asking that. We'll go ahead and start with you, Eric. And this is Eric speaking. For me, I've been fascinated with technology since a young age. For me, technology is comparable to magic. It's real magic in our world.
Yeah. Mm-hmm.
This is Scott. Thank you so much for that response, Eric. Linda?
Well, growing up, I was always fascinated by water. I swam, went on boats, fishing, all of that. And so I learned the value of water since I was young. Look, I have a glass of water I'm drinking right here. We all require it to live. And there's Anne with her glass as well. Yep. So I wanted to research why the world doesn't hold water in a high regard. There's no respect for water as there should be. So in my research, I really want to focus on the conservation and preservation of clean water. That's truly my passion.
Thank you, Linda. And having that as a passion is important. If someone has a passion, they have sustenance and they can maintain that momentum.
That's right, says Linda.
Anne?
This is Anne. Really, I just could add on to what everyone has already said. There was a passion, a drive, curiosity as well. I've always been curious as a kid and my whole life. I've always been curious as to how the world works, and even, fireflies, and knowing that they light up, in that magical way that they light up. As a kid, I tried to gather and collect some fireflies. I put them in a jar because I wanted to see them. I waited to observe them, and I wondered how long they would light up for, and if they would still light up during the day. I had these questions, and after many of them died, I finally found my answer. Unfortunately, I had to improve my method. Capturing them wasn't a good idea. Also, I would often ask questions of my family members who were hearing and knew sign language. And also, I just would go out into the field. My sister also was very interested in astronomy. She was always into the stars, and she would talk a lot about the space and the stars. And I was outdoors a lot as well. My mother and my sister were very much into English literature, and I had a distaste for it. I would rather go outside and play. I was so curious. Even plants, I just wanted to know how plants worked and grew. And that same curiosity followed me through my life until now. I still have an interest in plants.
Hmm. Well, thank you so much for that as well. And you mentioned family and being inquisitive with them, and their responses helped you stimulate and continue that learning. Can I ask you, is there a role model from your youth that you can look back to and realize now that they did help push you along into the STEM field? Linda, why don't you respond first?
Well, my family read anything and everything. So I grew up my whole entire life around a library of books. We also would go to the library, so it's very important. I was exposed to English and to language, which can really help answer all the questions that you have about the world. Books can really show you other perspectives out and other cultures, how to investigate and research. So really that to me was key. All of that exposure to books growing up, really from the time I was a baby, that built a strong foundation for me. And I want to give a piece of advice to all families or anyone who is in the life of children: make reading fun. Don't ever force it, but make it enjoyable, play with it, and make it fun. Because if it's not fun to read, then that could be a barrier. Make it a game. Make it something that the child dives into themselves. It's very important. And if it's not fun, find a way to make it fun. That is my word of advice. That is crucial. Also, I'd have to say curiosity was the same for me. I asked a lot of questions. And then, I'd ask a question and they'd say, well, why don't you research it? Do we have a book on that? And if we don't have the book, what are you going to do about that? They would constantly challenge me. They would not give me the answers, but they'd challenge me to find the answers myself. That really gave me that ability to realize I can research this on my own.
Now, who was that pushed?
My parents, family, friends, people in my community.
So they're the ones that would say, go find your answer in a book.
Right. And sometimes they give me a part of the answer and then push me to discover the rest. And that was really important. Also, really, it's diverse. Sometimes reading something, I would learn things, or by doing it, I would learn, or from leadership or role models that I would watch. I never had one role model. I'd have to say there were many uh, role models in STEM. Looking back, all of that has been incorporated into the way that I teach my students. It's never just about me, it's a group effort. The educators are all around us.
You're talking about community learning
Yes,
with different skills and talents together. There's a lot
right. It takes a village to raise a child.
of, yes,
And if you don't have a way, then you can always find a way to make that happen.
so true, so true. Linda, thank you for your
Yes,
comment.
thank you.
Anne, can we turn to you?
When it comes to a role model that I looked up to,
Yes.
oh, I had many, just like Linda said. My parents, my sister, my family, they all were very curious in general. And I was very curious, like I said, always asking questions. And my family guided me. They helped me, encouraged me to read books. You should have seen my house stacked with books upon books everywhere, every nook and cranny, every space. My family was very passionate about books. And also, my favorite third grade teacher. She was my favorite teacher. She was very patient. I was mainstream growing up, and my third grade teacher would allow me to ask any question when my class would go to a field trip. For example, we went to the beach on one field trip, and I remember picking up a shell and asking my teacher all about the shell, and she was so patient. She answered all of my questions. So when I think about one of my favorite role models, I have to say one of my teachers, or one of my interpreters who taught me self-advocacy and self-determination. She really just let me know that I can do it.
And this is Scott. And thank you for your comment. Thank you.
Yeah.
Eric, we'll turn it over to you. Well, I have to say I grew up identically to how you both did. I was a big bookworm growing up. I was a voracious reader. I would read anything I could get my hands on. I knew a tidbit about everything when I was a kid. And as I grew, I started honing my focus to the major I'm in now. For my role models, I would have to say I had many, many different role models. My parents, for sure. A couple interpreters, maybe even. As far as teachers, definitely. And a few others, I'm sure. This is Scott. So all three of you had a variety of people stimulating you and encouraging you along the way. And as you continued your life journey, those people continued to be around you and near you. That sounds really nice. Anne, you want to add something?
Yes, I wanted to say my life took, the path of where I met a lot of amazing people, just coincidentally, people who came along that I looked up to. And that was really awesome.
This is Scott. Thank you so much. Now our audience has an idea of who we're speaking with tonight. Move on to the next topic now. Now, let me ask, how have you been using your education or what you've learned to navigate your STEM experience? So basically what I want to ask is about your degrees and your studies. But before that, how did you decide on that major? How did you come to that decision? So Anne, why don't we start with you?
This is Anne. Well, science. I loved science. I also was a bookworm. I always loved plants, being outdoors. I loved animals. Plus, I started with my bachelor's degree in biology in college at undergrad, Connecticut College. It was a very small school, but had a really good science program. So I started off as a biology major and jumped between horticulture and ecology. There were a lot of classes I took in my decision-making process. I knew I wanted to study cancer as well, but I didn't find that that was a good match. The reason I wanted to study cancer is because one of my favorite interpreters died from cancer, and I was determined to find a cure. But I decided to drop that after getting a taste of the labs. I knew I had a dislike for that. Then I wanted to try microbiology and ecology research. And those plans actually ended up getting dropped out of my control. And I was searching for a job, and having a STEM mindset, I knew that I had to look for something on my own. I had to advocate for my own needs to find something that was a good fit. that I wanted. So actually I found a job as a landscaping assistant at a arboretum, just like DC, Washington, DC's arboretum, which is beautiful. I fell in love with identifying trees and plant diseases, and the lab work was not something that I knew I was interested in. I wanted to do field work. So I took the opportunity to become a farmer and farm educator. And I wanted to get into sustainable farming. And so I entered Colorado State University for my master's program. That's where I started. And my first advisor stepped down, and I got into I was interested in fruit crops, various different types of fruit crops, and the study of that. But the department, my horticulture department, really, they are the one that told me about the opportunity in viticulture. And I knew at the time that I was interested in grapes as well as other type of fruit crops. And so I started to do the research of wine grapes, and I worked with growers and winemakers. And I got to taste wine and really work to figure out problems and their solutions. For example, there's one particular pest problem that they were facing, and they didn't know what to do with it. And I taught the growers what to do to overcome that pest problem, and I just fell in love with that. So when I entered my PhD program, I knew I wanted to become a professor and uh, by extension work with growers and to help people set up their vineyards. And yeah, so that's been it. I know I went very long there with that answer.
And that's not a problem. Thank you so much for your response. Eric? And this is Eric speaking. I went to RIT. Well, I was there from 2004 to 2006. I dropped out in 2006, which was a long time ago. I restarted in community college because I realized that I wasn't ready earlier. That first time, I just wasn't ready for the college experience. It's a long story. Anyway, I went back. I went to community college in my home state, Washington State. And I improved. I was studying mechanical engineering. That's what was available in that area. And so I was making progress as a student, and I got better and better. I transferred to a university in Canada. It was focused on physics and astronomy. And I was interested specifically in designing space missions on other planets. And so that was a class that provided that opportunity and that pathway. So I got to work with professors at the university there who ended up writing 2 peer-reviewed papers. So I ended up writing 2 peer-reviewed papers. Scott says, you have 2 published papers. This is Eric. Yes, I do.
Wow, that's an achievement.
This is Scott. Wow, impressive. And this is Eric. Yeah. One was after my undergrad studies, and another was while I was doing my master's. But yes.
And says, same here.
Also, this is Eric. During that time, I got more interested in human spaceflight. And then I began thinking about chemical engineering. And I was trying to find a professor who was also working in that direction. And so that's what led me to the University of Florida. This is Scott. Okay, so then you became interested in chemical engineering, and then you decided to find a program and a professor, and you're saying through that you found a program at the University of Florida, and now you're studying chemical engineering there. This is Eric. Yes, this is Scott. So you have hopped around as well, right? there's a couple of you that have hopped around and then through that hopping around, navigated into your STEM field. But
Yep.
it's at every step of the way, you're narrowing down those career options. Linda.
This is Linda. Yeah, so for me, really, it was my love of water. And I entered into engineering. I was thinking of environmental or possibly civil engineering. And I realized I really didn't enjoy that. It was very heavy in classwork and the information was overwhelming. I really just didn't feel ready for that. So I transitioned over to environmental and ecology. What was your sign you used, Dan, for ecology?
Yeah,
Okay.
ecology kind of twirls
This is
around.
Anne. I can expand on where I learned that later. This is Linda. So yes, I became fascinated with ecology, and it was challenging, but it was a great fit for me. So I pursued that field.
And this is Scott. It's the concept of understanding ecological concepts, and then engineering concepts. They just didn't feel like a fit, but those ecological concepts just clicked for you, right?
That's exactly right. Yeah, and I took that with my first classes. They were really beneficial. I learned how math applied to the work, about designing things to solve problems, and I so those classes I took in civil engineering, I feel were not a waste of time. I still carry that information with me, and they were a benefit. So yes, then I graduated and thought about what I wanted to do, if I wanted to work or not. I did work for 1 year, and as a professor, I touched on many different things, and I decided to get my master's degree
Dance.
at
Yeah.
Manif. Worked with water there, and I looked at how contamination can come from very far away and end up in a particular place. We analyze water and how that goes up through the food chain. Those contaminants go up through the food chain. So it was a great learning experience. And I attended conferences and workshops and events with different professors in Canada, and which is a normal part of the field to just meet others. And I met one professor who worked in Eastern Africa, and I approached and asked if he needed any help, and the answer was yes. So I moved there and worked for 4 years in Eastern Africa, focusing on contamination of Lake Victoria, which is the largest warm or largest lake in the world. And that's really what was great, is that the African people taught me. I wasn't going there to teach. They, in turn, were teaching me their practices and how to take samples and so on and so forth. It was a really enriching experience. I learned a lot, and a lot of that I brought back with me to Canada. And those teaching skills that they used to teach me, I brought back with me when I started thinking about people in the Northern Hemisphere, how instead of just so focused on where we live, but thinking more broadly about the world as a whole and the importance of that, just seems like the Northern Hemisphere, North Americans and Canadians are pretty isolated. We don't have a whole world view. That's both countries I'm speaking of, not just one. But I ended up going back, and I realized after working 4 years in Africa, I learned a lot. And when I came back to Canada, I was thinking of how to reciprocate, thinking about behaviors through life and communication that promote respect. Really, all of that helped me. That helped me through my whole career, learning to respect everything. I also worked a little bit for the
That's how you
government. The
cover.
government. This is a Canadian sign for government. Yeah.
Yeah.
And I worked for the Great Lakes, doing similar type of work. And then I became a professor in Ontario and moved then here to where I am now, Nova Scotia, Halifax. And now my lab, my students, my PhD students here, you know, it's amazing. I look back to myself as a PhD student, and I look at these students and their maturity and their leadership skills. It's truly inspiring.
Thank you so much, Linda. Nice.
Thank you.
Okay, there is a question that came from the audience. I know it was for Anne, but I'm sure it applies to Eric and Linda as well. The question is asking if you work with any other deaf folks. And if so, is that in the lab, in the field, or in what environment or what setting are you interacting with deaf and hard of hearing folks? We'll go ahead and start with you, Anne.
This is Anne. Okay. I just saw the Q&A box pop up with the question. So yeah, there's really very few deaf people in the winemaking field. And I am really wanting to see those numbers grow. I want to see more deaf people in horticulture and also in the winemaking business and breweries. There's a few deaf people who have breweries in Washington, D.C., Indiana, and I think maybe Austin, Texas. But as far as wineries go, I know one in Tuscany, Italy. That's deaf owned. Yeah, the only one. I would like those numbers to expand. I want to see more deaf people in this business. So anyway, I could go on, different plans and ideas that I have, and I can share those later. But I'm working with a deaf PhD student who is a plant pathologist, and this person is deaf-blind. And so there's only two of us in this field. There's not enough deaf plant scientists out there, but I have heard there are deaf people in other fields like ecology, marine biology, and so forth in the sciences, the greater sciences. So yeah.
Anne, thank you so much for your response. Eric? I would like to add that I am in touch with a few other deaf employees who work at NASA that are also engineers. I know that there are two more at SpaceX, the private rocket company, SpaceX. There are deaf employees working there already.
Cool, says Linda.
But none from your program. No, not. But you do know several people in your field that are also deaf. Yes, that's correct. Okay, Linda, what's your response?
In my field, there are no other deaf people. From every once in a while, I'll have a deaf person join my research group cohort, and that's really nice to have that involvement. But as far as classes go, I don't often see any deaf people. It's strange because we'll have an interpreter sometimes for a deaf student in my class, and I think I would be able to, sign directly with the student, but it's very strange. So my interpreter is there for all of the students, but they're for the hearing and students who need an interpreter more than me. I can sign, and these hearing students do not have access. They don't know sign language. So anyway, it's a good blend having these different interpreters in the class for these different purposes. However, my field now, there are two deaf professors doing what I'm doing in the whole world right now. Myself and one at Gallaudet.
And you're talking about environmental sciences specifically?
Yes, specific to water. So there's only two. Now for ecology and environmental scientists, there are several, however, no professors in those fields. So right now, There are a few more deaf students who are graduating and working in aquatic science. So those numbers are growing. Just this past May, I went to the deaf
So what's this sign you used?
academics.
Okay, thank you.
That's the sign I use for academics. It's a European sign. However, so I went to this conference. There were actually 4 of us there who presented about deaf people focusing on aquatics. There was myself and 1 other deaf professor and 2 other hearing professors. And it was a great experience because really we all had the same experience. Looking for a way to give back. And it's difficult to do that because of communication. You know, you get the experience, but then how can that experience then be passed on? How can you be a role model to continue passing that on? So that's something I'm working on now. Very hopeful that the group of 4 of us will expand and we can support new students coming in.
Suzanne, definitely. And this is Scott. Very true, your comments. Linda, we do want to expand those numbers.
I want to see them grow and grow.
Yes. The purpose of these webinars are to have you serve as role models for students. Right now that they're in high school, they can focus on STEM. And we know that there are lots of areas where they can work. And so we're trying to do this to provide that help as well.
That's great.
So Linda, you brought up a good point in regards to sign language interpreting. I'd like to ask how you set up your accommodation services, whether you use sign language interpreting services, CART services, or any other type of service. And if you do work with an interpreter, typically your field has its own vernacular, its own lexicon, and sometimes the interpreters don't have that. So how do you address that and how do you deal with that? Eric, why don't we start with you? This is Eric speaking. Sure, Scott. I have some experience from my undergraduate studies in regards to what I've done with coordinating the interpreters. Sometimes I'll have 2 or 3, or have had 2 or 3 interpreters, but I maintained the same individuals for that whole time because they knew me. And Scott says, okay, so you work between those 2 or 3. Right, they understand me and they get me. And this is Scott. Do you have any other accommodations that you've used? Well, if you want to know what I'm using now, I'm using captions online and also on videos. I have started using this system before coronavirus pandemic started. So I was using the caption system and I feel that it works really well and it's a little more useful than having an interpreter. The last university I was at didn't have that and didn't provide that. And so I'm really glad that the University of Florida does offer that. This is Scott. Okay, so you have a preference and an affinity for the captions, Eric. This is Eric. Yes, I do. Okay, Scott here. Linda?
Undergrad, all the way through 4 years, I did not use a sign language interpreter because I felt like there would be a barrier to the information and that I would have to do extra work. I'd have to read the book and analyze what the interpreter is trying to sign and do the coursework. And it was too much work for me. So I had a friend who sat close to me and would take notes. We became a team. I would bring in the book and my friend would take notes and then I would add to those notes. If there was something that was missed, I would look it up and say, you know what, you can find it on page 40, whatever. And so we worked together as a team in that way. And I feel like that really was the best use of my time. If I was to sit there and watch a sign language interpreter all day, it would just tire me out. This was the best way for my education. It really worked well. So as an undergrad, I'm really thankful I had a lot of volunteers to take notes. Everyone wanted to work with me, and really that helped their note taking. And in exchange, I would give them something, a gift for Christmas or a card to thank them. And then when I went to grad school for my master's, it couldn't work that way any longer. And that's when I started to work with an interpreter for the first time, and it was a rocky start. I became an independent researcher, and the model of having an interpreter standing up in front of the class signing was not going to work. So I had to get rid of that model and think of a new way, a new model for the interpreter, to use the interpreter. And the interpreter really wasn't there for me. They were not a good match for me because I was really intelligent. I had a lot of knowledge about these things. I simply needed access. That was important.
And challenging.
And they needed access. As a lecturer, there were signs that they didn't know. They didn't know how to sign what I was trying to lecture. So over time, we became equals, myself with the whole group. And everyone viewed sign language and spoken English equally. So we had to get rid of that preset model and think of inclusiveness.
Inclusiveness, you just said it, yes.
Right? Because the accommodation wasn't really for me, you know? Inclusiveness is for everybody. And so finding that really helped, you know, and I explain and say this interpreter's here to help everyone in the room understand one another, you know? And so they're thought of as part of the team. It's not like, you know, the onus is all on me. The onus is on everybody to make sure the communication is clear for everyone.
And not only that, with that, there's communication, pre-communication before class, a lot of discussion.
Right. And I was able to dramatically decrease after this because I would develop trying to think of a lot, and I put a lot of time and energy trying to think of the best approach, and I would get angry about that. And I was trying to analyze why I'm angry, and it's because it was all put on me to figure out. So shifting that focus really made everyone an equal party. So then on to my PhD, I had 4 interpreters, and at that time, I wasn't afraid to raise my hand and jump in. And so the 5 of us would work together and think about what the role of an interpreter was and what that meant. You know, you can't just be a helicopter interpreter, drop in and interpret and then fly out of the room. But, you know, we would get together for long periods and have discussions over coffee and figure out what worked and what didn't work. We saw each other as peers. We were equals studying the language. So in my PhD program, it became more clear that I wanted that as a professor, I wanted to ask for an interpreter right away. And so I had an interpreter with my class, and there was another interpreter for the deaf student, say. I had to argue my position first and argue to get what I needed first in my contract, and then negotiate the interpreter as a separate piece.
Fascinating, Linda.
So I actually was involved in drafting the job description for the interpreter. My they're to be a part of the interpreting process and the interpreting decisions. So when I go to class to teach or go to workshops or various different places, I can sign freely and then leave and go home. And I feel like that's a major accomplishment. And, you know, deaf people in the audience don't know what I'm saying if they don't have access, if they don't know sign language. And so the interpreter's there for them, not for me. It's all in how you frame it. But I feel like that has been very helpful, taking that huge burden that was placed on me. And there's still a little bit of burden on myself, but we share it now amongst the team. And it's also important to grow your pool, which means it's not a good idea to rely solely on a few interpreters. You should always try to add more interpreters to your pool and expose them to the content. Maybe having 5 or 6 interpreters who are truly experienced in the work, but always look for new interpreters, newer interpreters, and encourage them not to be afraid to just jump in.
About a pipeline, setting up your pipeline.
Right, and having that benefits deaf people too. Then you don't want interpreters that are afraid of science and scientific terms. You want them to feel like they can do it. They just have to think about it. So we've grown our pool of staff interpreters and talked amongst ourselves and how we can grow our pool and expose them, maybe through internship opportunities or observation time, having interpreters come. So we have 5 experts, and then we're always adding as well to that. But being a student is really difficult going through the system, and so you have to close the gap and try to think about how to resolve these interpreter issues from the get-go.
This is Scott speaking. Thank you so much, Linda. No, don't worry about going long. We are getting close on time, though, so we will have to keep our responses short. And
This is Anne. I'll be short. So my interpreter experience was pretty similar to what the two of you already said. I have a team of, I'd say, 3 to 4 interpreters, but interpreters are hard to find. And so we have 2 excellent interpreters because, your PhD program requires independent work and independent research at a very advanced level. The expectations I even have for myself are quite advanced. So I need a very professional interpreter that can just roll up their sleeves and get in there and do the work. So I have taught my 2 main interpreters terminology that applies to my work. I've basically trained them in the vocabulary, and I also use captioning because of ever since coronavirus and the shift to online classes has happened, I use captioning. And so I use both an interpreter and captioning at the same time, and that's truly beneficial. For example, I'm taking statistics, organic, chemistry, and other really difficult classes. It's beneficial to have both. Also, having real-time captioning on my phone as I'm doing field work. I have my phone out in my hand, and I can lip read and speak, but it's exhausting to lip read all day and try to process what's being said. So I have a real-time app on my phone that's called Otter AI, and I have to tell you, it is amazing.
same one, says Scott. And Eric says, so do I.
Oh, it is the best because it really captures everything that's said. Just like on Zoom, I'll struggle trying to lip read, and sometimes the audio is disjointed with the picture, the video. Same thing with conferences, I can use it, like Eric was saying. Unfortunately, I was not allowed, or they would not pay for me to bring my own interpreter with me for the conference. We had to find a local interpreter, the place that the conference was held, and I had to sit down beforehand and give the terminology to the student, or I'm sorry, to the interpreter who was just shaking in their boots. So my recommendation is for an interpreter to maybe pick a field, a major, let's say biology, and then have a double major in interpreting. And you follow both paths at the same time. That way you have that background in that particular field, like biology, and you'll have a greater understanding, which will aid your interpretation.
This is Scott. Well, thank you for that extremely good advice, Anne. We are running low on time, so we have to move on to the following topic. And that question is, what advice do you have for any deaf or hard of hearing K through 12 teachers or educators teaching STEM as they prepare their students for higher ed? Now, if you can do really brief responses, Linda, let's start with you this time.
This is Linda. What was the question? I'm sorry, I had to move a screen over. It was blocking you.
Yes, what advice do you have for any classroom teachers to help their deaf and hard of hearing students prepare for moving on to STEM in higher education?
This is Linda. Oh, teachers can show their passion and their love for STEM because when it's inside you, don't show that you're nervous or don't show, any kind of weakness. Show that it can be done. Provide the resources, the books, and the encouragement. Don't show the negativity because, a lot of people have a fear of math, and it's normal. There's so many people who have just an internalized fear of math. So I'd say accept it and move on. Don't transfer that fear of math on to the students that you're teaching. Really think about how not to do that.
That is so valid, Linda. Teachers they avoid teaching content that they don't like. And so we've got to get rid of that attitude.
Right, and it's tough. Yeah.
Yes. Sorry, we've got to move on. Anne, go ahead, Anne.
This is Anne. I plan to say a long list of pieces of advice, but I'll try to consolidate it to 4. The first one is having a Skype scientist program. So for example, if you click a button for Twitter and you're able to Skype with lots of deaf scientists and deaf people in the room, why not collaborate? Why not join those together? Second thing is I will Skype with the classroom. I'm looking forward to that opportunity. And teach those students how not to be afraid to ask questions and to write as much as they can down. My parents really honed in on the importance of writing, and writing is a very important skill for science. You've got to get your writing on par. Yeah, that was my last one. Well, we can move on.
Thank you, Anne. Yes, thank you so much. Eric, this is Eric. I've got one more comment to finalize tonight. Important skill to have is to be able to self-advocate.
Anne says yes. Yes.
You've got to teach your students how to self-advocate. They need to know how to get that done.
Yes.
There are many barriers and frustrations on the way. It's a tough system to have to navigate.
Linda, especially in STEM.
This is Scott. Thank you for that final comment, Eric. At this point, we've got to move along because we only have about 5 minutes left to wrap up tonight. I do want to share some resources that we have put together. You can see them on the PowerPoint. These resources are focused on K through 12 and encouraging those students to feel more comfortable diving into a STEM field and preparing themselves for that higher education. Those PowerPoints will be shared with everyone. And moving on to the next slide, is I strongly encourage folks to join professional organizations. They have plenty of resources already available excuse me, to that organization. A lot of these professional organizations also have subgroups for minority folks that aren't too well represented in our STEM field. And it seems like you really want to add something.
This is Anne. Yes. I just saw some questions pop up about involving minorities. And that really is beneficial to me because there's problems that I often am faced with. And, oppression, you want to remove that. And so working with people of color and meeting various different people, it really gets my mind going on how to solve this problem. And I approached, just like the idea of having a black wine maker. That's just another idea I thought to throw out there.
And I appreciate that comment. These are science ASL focused websites that have terminology and concepts in American Sign Language. Again, we encourage you teachers that are here tonight to share that with your students. And again, these are classroom materials now on this PowerPoint that can be used in the classroom and curriculum, and it's constantly updated. There are different areas of focus, and we have different experts located in those links to those resources in that PowerPoint. And the following webinar that we're going to have is next week, Earth Day, April 21st. I just want to announce that. It's got a middle school student focus. So if you know any middle schoolers out there, please tell them about our live webinar. It is free, and we encourage you to promote that to your middle school students and have them join us next week on the 21st. This is Scott again. I'd like to thank everyone on the panel. I appreciate your comments.
Thank you.
And the audience, all of the folks that are here with us tonight, thank you. If this was your first time joining, I do want to let you know that we will be sending out a survey. We would appreciate your feedback in regard to tonight's webinar. Now, with this webinar being the last in a series, it doesn't mean that CSD Learns is done providing this educational material. We do have a STEM toolkit releasing soon for teachers and educators, and the team here is continuously working on developing more and more resources. As we identify challenges in these webinars, we develop materials to address those. So we appreciate your comments, your feedback, and again, I'd like to extend my gratitude to everyone here tonight. Thank you so much, folks. Stay safe, have a good night, and practice social distance.